Okay, hi everyone. My name is Andriy Kokhan. Today, together with my colleagues Taras from PLVision and Ankur from Keysight, we are going to talk about SAI expansion in modern networking world, SAI use cases, and SAI challenging. So, as all of you know, initially SAI was developed for the switching silicons use case, but for last few years, many new use cases came to the stage. And we see particular gap between how we used to test SAI use cases and what we actually need. So based on our experience and our vision, we developed and contributed to OCP SAI Challenger framework. Also, Keysight came up with a great idea of Open Traffic Generator API and their Python implementation Snappy. So we decided to combine our efforts, but let's take a look at SAI ecosystem first. So I believe now we need to add one new component here, IPDK. That was great presentation and great vision, I guess. So initially, as I mentioned, SAI was developed for the switching silicons, integrated into different type of networking operating system like Sonic FBOSS. Then extended with external file support, dash use case with static workloads, before programmability for SAI pipeline in pins use case. And there is one component which is usually common for all these use cases is syncd daemon. Why is that? Probably because it's simple, it's well designed, it's stable, and still contains some common logic for all these use cases. For example, object discovery. So that's the basic idea behind SAI Challenger. So we created Docker-based environment, which is running syncd as a SAI driver inside, provided simple Python CRUD API on top of Redis database. And with this simple solution, we can easily do SAI integration and testing in one shot. We can make simple prototyping in Sonic light way. Also, we can easily reproduce user scenarios based on SAI Redis reg files, which we can take from Sonic environment. We also have like tooling like CLI for that. But with those new use cases, we had to add new features, so we had to be in the same pace. So we added flexible SAI configuration possibility. We will talk about this in a minute. We added pins use case support, just as an example how we can prototype with SAI Challenger. Multi-dude support, so you can build simple topologies. Starting to add different ASIC simulators support. And also you can build more complicated SAI-based topologies with GNS3 framework. And also you have things like extending logging capabilities and so on. And the last but not the least is the data plane testing. So as one of our customers say, ping is not a test case. So we need to be able to send more than one packet. So Ankur, I would like to ask you to share your experience about this.
Thanks, Andriy. So I'm going to talk about traffic generators, okay? And with full acknowledgement to the previous speakers who said in all their test cases, 10,000 plus, they do not use traffic generators, external traffic generators. Completely understand that use case, totally agree with what they're doing. But there are many use cases where you need external traffic generators. And the state of the art few years ago with external traffic generators was they were hard to use. They were hard to use in automation and so on and so forth. And so working with some customers, Keysight, formerly Ixia, created this new open traffic generator APIs, okay, for integrating test cases, writing test cases and integrating them into your CI/CD pipelines. And the idea was very simple. Come up with an API which is open, model-driven, declarative. Write your test cases once, run them all the way from simulation to system test cases, okay? We ended up picking OpenAPI v3 as the modeling language for this API, which automatically gives us SDKs in any language that you would want. We went a step further and created native SDKs for Python and Golang called Snappy, which I'll talk about in a second. The premise behind the API, besides being open and model-driven, is that we wanted a clean API that was easy to understand, well-documented, flat, and wanted to provide both transports, REST and gRPC. So let me show you what this means in reality. You have your API, which is specified in YAML files, available on GitHub. Using that API, that YAML, you can use open source tools and generate your client-side SDKs in the language of your choice. Or you can use Snappy and GoSnappy, which is something we've also created and open sourced. You write your test cases using these SDKs. And these SDKs, these test cases then run against an open traffic generator compliant traffic generator, open traffic generator API compliant traffic generator. There are a few out there. T-Rex, everybody is familiar with. We wrote an adapter for that. There is an XCSC traffic generator, which is available for free from Keysight. And we also support Keysight's well-known traffic generator called IX Network. A little bit about Snappy. It's a client-side SDK, as I talked about earlier. It gives a lot of facilities that Python users are familiar with. It's really easy to use, easy to understand. I've got a short, small diagram here showing the ease of generating traffic. Anybody who looks at that script can tell right away what kind of packets they're going to generate from the traffic generator. It's available from PyPy. You just do pip install Snappy, you get it up and running in 2 minutes. Last word on what is the status of the API as it is right now. It supports full layer 2, 3, 4 traffic generation and analysis. We've got an increasing set of protocols on the device emulation side, starting with BGP, ISIS, LACP lag. RSVP is in progress. We're also working on HTTP support. It's a project we started almost 2 years ago, and we're working with several other stakeholders. And as a result of that, we are already present in many well-known ecosystems, whether it is SAI Challenger, what we are just talking about right now. Sonic PFC test cases use the same API. We're integral to a couple of emulation platforms, KNE and Container Lab. KNE, for those of you who are not familiar, is Kubernetes network emulation. It's a Google-supported project, and just this week it was announced at a major way at Nanog down in LA. We are part of that right from the get-go, and we're integrated very well into those. We still work in progress. These APIs are still work in progress. We expect to hit version 1.0 sometime in Q1. We've laid out some goals and some criteria for us to hit those. We expect that in Q1. I'll just end before passing on to Taras by saying, inviting you all to try it out. Go to otg.dev and take a look.
Yeah, thanks, Ankur. So Andriy was talking about the SAI Challenger and Redis and SyncD, how it was designed, how SyncD stable is, and how we can do a lot of different things like pins, etc., etc. But I believe people that are working with Sonic or with SAI knows that SAI nowadays tests with a bit different approach. There is a shrift. So what to do with shrift? Okay, we can do simple things. We can just ignore and say, okay, we are doing the best, but we can pull it in. Why? Because we can. And the long story is because sometimes you don't have the full SAI that, or the SAI that is capable enough to cover the SyncD integration. So with pulling in the Shrift as the yet another interface for configuring your SAI allows us to enable the early adoption and the early validation of the new devices, new libraries, and new vendors that are trying to get the SAI or to implement the SAI. Which leads quite interesting to the following use case. It's the Dash. I believe a lot of you might heard about Dash. It's the disaggregated Sonic for host, a really interesting use case. And one is the outcome that vendors are being asked to provide a SAI for the Dash use case. At this moment, if you will take a look on the open source, at least as of several days ago, there is no SyncD, so how to test it? You can use Shrift, yeah, but how to make the validation on the scale? You can use PTF, you can send several hundreds of tests, but how to test the millions of flows and the CPS? You need the traffic gen. So what we've decided, let's take the SAI Challenger existing integration with OTG, which allows us to get the XCSC and software-based, write the test using the Shrift, and test it on the simulation or the early access device or the access library, and then scale it up to the hardware within the same test, swap the XCSC with IX network, swap the simulation with the real hardware, and you have the profit because the test case remains the same. So as a conclusion, this is how SAI testing we see. There is a hardware, and I specifically put it hardware because now it can be NPU, IPU, DPU, and the PHY. Because PHY also now is controlled by the SAI, and there is also a need to work with it, but how? And this is interesting. This is so-called multi-dude. So we are treating SAI and we are treating devices as the object within the test. So we are defining that we have this PHY from vendor X, we have this NPU from vendor Y, we might have this Dash appliance from vendor Z. We bring up the topology, we're removing all control plane out, and we are saying this is what the control plane is doing, and we are testing what are the expectation with the OTG and maybe other tools in the future. So the whole idea, we can simulate the complex network designs and test them on the SAI level. Starting as the one object, it can be either NPU SAI, PHY SAI, or DPU SAI, and scale it up to the complex topologies, remove the complexity and bugs of the control plane, because let's be clear, control planes does have the bug. And what's most important, we do provide the simple and understandable playground or maybe neutral ground for the vendors, because it usually happens when you have several vendors in the table, the finger pointing starts, but if you say, this is the SAI configuration I did, this is what I expect, and it doesn't work, and this is the simple tool, open source, which you can test and recheck it within your lab, it's make life of the integrator much, much more easier. So what we would like you to take a look at. We encourage you to try. It's available on the OCP GitHub. We are encouraging you to port it to your either use case simulator or hardware. We do have support for Tofino now, has been added, and a couple more in plans. We encourage you to scale it. Start with XCSC. It's the great tool. Download it, free of charge. Get the packets out from the device under test, and adopt it. So once you have your use case written within the pure SAI configuration, you will know for sure this is what you will give to your vendors, and this is what you will give to your control plane developers. So it's clear and simple division between who is responsible for what. This is the vendor's responsibility. These are the control plane responsibility. Thanks.
Thank you. Questions?
I have a quick
question on, by the way, great talk. Thank you. So you mentioned about GNS3 earlier on, and if I recall, on today in the Sonic environment, we use Sonic VS in the GNS3 to carry out essentially the management plane and control plane testing. There is no data plane and there is no SAI in the GNS3. So do you want to, just talk about what do you mean by using GNS3 for the SAI testing? Because there is no SAI there as far as I know.
Yes, that's actually a great question. So a GNS3 use case is more about prototyping, but not testing, I would say. As you just mentioned, there is no data plane in GNS3. And as you just mentioned, actually, there is SAI-VS inside Sonic. So with this idea to take SyncD together with SAI-VS, so you don't need to wait for your hardware to start prototyping. So you basically can just spawn number of Dockers, connect them together in GNS3, and start making the configuration either through simple SAI CLI that is available in SAI Challenger, or through some of the available interfaces like Shrift or CRUD API on top of Redis. So that's how it works.
Okay, all right, thank you.
Sure.
I have a question about your snappy test cases. Are you already upstreaming it to the Sonic management repo?
So currently, so it's not the part of Sonic management. It's a separate repo in OCP community. It currently contains a subset of test cases, just an example how it can be used. Specifically, we focused on the read scenarios. So we have simple approach how to retrieve, let's say, all attributes in read mode. And now we are extending it for dash use cases. Yep.
I'll just add that there are Snappy-based test cases in the Sonic management repo already for testing PFC.
Yeah, they have a QoS test, like a PFC,
Yeah.
the ECN, those.
Yeah, those are already there
Yeah.
using Snappy.
Yeah. And you also has it work with the XCRC?
Those PFC test cases don't work with XCRC because PFC requires a hardware-based traffic generator. XCRC is all software, a software-based traffic generator. But they work with other Keysight's hardware-based products.
Okay, thank you.
And what we are actually currently doing in the process, we are developed the POC level use case for the Dash, which we are in the process of putting it to the Dash. Then thanks.
One more question. Yeah.
Oh, sorry, it's quite a bright light. It's hard to see.
Yeah, very interesting presentation. The question was, what is the traffic rate you support with the OTG?
Oh, I believe Ankur can answer, but I can say starting from 1 packet and up to the highest available.
We had tested up to 400 gigs line rate with OTG. So it works with Keysight's commercial traffic generators, hardware-based.
So the whole benefit of this OTG, you prototype with the emulator, XCSC, which is, I mean, you can give to each and every developer. And when you need to test, you run on the like 6-figure traffic gen, which can do line rate. And the same code, same exact, I mean, no changes needed, only the config file where it was.
Thank you, everyone.